Forces due to system of multiple charges. In this, we have to take the three charges as a system, that is q1, q2 and q3, in the three-dimensional space, that is x, y, z, and O is the origin, and the position vector of q1 is r1, position vector of q2 charge is r2, position vector of q3 charge is r3, and we have one test charge, that is q naught, on which we have to find the resultant force due to all these system of charges. So for finding out the net force on this test charge q naught due to the other system of charges, we have to apply the superposition principle. So what is superposition principle telling? In this superposition principle, according to superposition principle, the total net force on any test charge due to a number of other charges at rest is the vector sum of all the forces on that test charge due to system of other charges taken one at a time. So by this superposition principle, we understand that we have to take the vector sum of all the forces due to other charges, and we have to take one by one into consideration. Like for example, in this q0 is the test charge, q1 is the first charge. Due to q1 charge, the force on q0 will be in this direction, and that force will be f01. So first we will consider the single charge, that is q1, and the force exerted due to q1 on q0 will be f01 in this direction. Then second, we will take q2 charge, and due to q2 charge, the force on this test charge q0 will be in downward direction, that is f02. Then third, we will take q3 charge, and due to this q3 charge, the force on this test charge will be in upward direction, that is f03. Because both the charges are positive in nature, so there will be a repulsive force in upward direction. In the same way, both the charges are positive in nature, so there will be repulsive force in downward direction. So when we have seen that all the three forces due to this three system of charge, so the net force will be the vector sum of all the individual forces taken one at a time. So the force due to the individual charge is unaffected due to the presence of other charges. Now we have supposed this given example. Suppose the charge is q1, q2 and qn is situated in the space having the position vector r2, r3 and rn. Here we have taken only the three charges. Now we are generalizing the case for n charges having the rn position vector with respect to origin. So in general, the total net charge f0 on test charge q0 at position vector r0 due to all n discrete charge can be written as the vector sum of all the individual forces, that is f0 total net force will be equals to f01 plus f02 plus f03 and so on up to f0n. So these are all the vector sum of all the individual forces. f01 is the force on q0 due to q1 charge. Similarly, f02 is the force on q0 due to q2 charge. Similarly, f0n, the force on q0 due to qn charge. So according to Coulomb's law, we say that f01 force will be 1 by 4 pi epsilon naught q0 q1 upon r1 naught square in the direction of unit vector r1 naught. So this we will be writing in this way: 1 by 4 pi epsilon naught q naught q1 upon r1 naught whole cube r1 naught vector. In the same way, we will be adding the other vectors in this form. That is, F naught total net charge will be 1 by 4 pi epsilon naught will be common. The first force F naught 1 will be Q1 Q naught upon R1 naught square R1 naught unit vector. Then F naught 2 force will be Q naught Q2 upon R2 naught whole square R2 naught unit vector, plus in the same way Q naught Qn upon Rn naught square into Rn naught vector. So this net force can be generalized in this way: 1 by 4 pi epsilon naught summation, that is I is equals to 1 to n q naught qi upon Ri naught square into Ri naught unit vector. So F naught net force will be 1 by 4 pi epsilon naught summation I1 to n q naught qi r I naught whole cube into Ri naught vector. Because unit vector can be converted in vector form, r cap will be r vector upon its mod value. This is the unit vector. So we are converting this unit vector into vector. Now here n is equals to 3 because we have only the 3 charges present, q1 q0 and q1 q2 and q3. So the net force will be 1 by 4 by epsilon naught I is equals to 1 to 3 summation 1 to 3 q naught qi by r I naught whole cube r I naught vector. So final result can be written in this way: final result will be F naught total net force will be 1 by 4 pi epsilon naught q naught q1 upon r1 naught whole cube r1 naught vector, q naught q2 upon r2 naught whole cube r2 naught vector, plus q naught q3 upon r3 naught whole cube r3 naught vector. So this is the final result we are getting.